In number 8, we're asked to calculate the distance between 2 points. Okay, so here are the 2 points, and let's write down the square root and the 2 parentheses squared of the distance formula, and in one set of parentheses we're going to subtract x values, so let's do that. So that will be minus 3 subtract 4. And in the other set of parentheses we subtract y values, so that's 2 minus 5. So here we have minus 3 minus 4, that's minus 7. Minus 7 squared, that's 49. And here we have 2 minus 3, that's a minus 3. Squared, we have 9. Okay, so that's the square root of 58. In number 9, we want to test for symmetries of the graph of y equal x times the square root of x squared plus 5. All right, so let's just review the various symmetries and how to test for them. So first, symmetry with respect to the y-axis symmetry. If we replace x, or we can say replace, say, xy with minus xy, and the equation remains the same, then we have symmetry with respect to the y-axis. Now let's look at symmetry with respect to the x-axis. Okay, well that will occur when you replace xy with x minus y and the equation remains the same. All right, and then we have symmetry with respect to the origin. And that happens when replacing xy with minus x minus y does not change the equation. All right, so in this case, the only symmetry that we have is symmetry with respect to the origin. So let's see that. Let's replace, we're going to replace xy with minus x minus y. So that would be minus y is equal to minus x square root minus x squared plus 5. And just simplify this a little bit. So we have minus y minus x. And here we have x squared plus 5. All right, let's, if we multiply both sides by minus 1 over here, we get y is equal to x times the square root of x squared plus 5. Okay, so what we did was multiply both sides by minus 1. All right, and then we see that the equation does not change. So we have symmetry with respect to origin. Let's look at another little example. Let's suppose we have this equation, x squared plus y squared is equal to 25. You might recognize that this is a circle, center 0, 0, radius 5. And if you can picture what that looks like, it really has all the symmetries, all 3 symmetries. Okay. And in fact, if we replace xy with minus xy, we get minus x squared plus y squared is equal to 25. Okay, and that's the same thing as x squared plus y squared is equal to 25. So that is, so then our equation is symmetric with respect to y-axis. Okay, because we replaced x with minus x and the equation remained the same. See? And if you do that, you could see that if you do that, the test for x-axis symmetry, replacing y with minus y, it's really the same type of thing occurs. Okay, there we replaced y with minus y. And you see if we just square that out, we have x squared plus y squared is equal to 25 again. So we have this time symmetry with respect to x-axis. And I think you could see that. Symmetry with respect to origin is going to occur as well. Okay, we replace xy with minus x minus y. And we have minus x squared plus minus y squared is equal to 25. And squaring out the parentheses, x squared plus y squared is equal to 25. So the circle is also symmetric with respect to origin. So this is an example. The circle is an example of a curve that has all three symmetries. Okay, so that's what we see here. We have all three symmetries. Okay, number 10, we want to form the equation of the circle with center minus 2, 3 and radius 5. So the general form for the equation of a circle with center hk is x minus h squared plus y minus k squared is equal to r squared, where r is the radius. Alright, so here we have the center minus 2, 3. So just filling in, that would be x minus minus 2, that would be x plus 2 squared plus y minus 3 squared is equal to 5 squared, 25. Here's an equation of a circle, and we want to find the center and radius of this circle. So we start by putting it in standard form. Alright, so we're going to put the x terms together. That's x squared plus 10x. And we're going to complete the square, so let's leave a space for completing the square. And then the y terms, y squared minus 6y, and another space. Now we'll add this to both sides. We'll bring that over to the right-hand side. And we'll put two blanks to correspond to these two blanks because we have to add the same thing to both sides. Okay, so here we're going to add half the middle term. Half of 10 is 5. Squared is 25. We're going to add that to complete this square. And here, same thing, half the middle term squared. That's half of 6 is 3. Squared is 9. So we're adding 25 and 9 to the left side of the equation, so we have to add that to the right side as well. Okay, so now these quadratics are perfect squares, all right, because we completed the square. So this one in x we have x plus 5 squared, factoring that, and then we'll factor this perfect square, and that's y minus 3 squared is equal to, and here we have 2 plus 25 plus 9, so that's 36. Okay, now that the circle is in standard form, we can read off the center. So the center here is, the x-coordinate is minus 5, and the y-coordinate is 3. And the radius is the square root of 36. That's 6. In number 12, we're asked to find a linear function. Linear, that means a line, such that f of 2 is equal to 5 and f of 1 is equal to minus 8. Okay, well that means that the line goes through points 2, 5. That's the x value, that's the y. And 1, minus 8. So we want a line through these 2 points. Well, we're going to find the slope of the line first, because we're going to use our formula y equal mx plus b. So first we'll find m. Alright, so we'll subtract the y values. Let's say 5 subtract minus 8. That's 5 plus 8. And 2 subtract 1. Okay, so the slope is 13. And if we start filling in our equation y equal mx plus b, we have y is equal to 13x plus b. And now we want to solve for b. So we'll sub in one of the points. Let's say we substitute 5. So that is 2 for x, 5 for y. So that's 5 is equal to 13 times 2 plus b. 5 is equal to 26 plus b. Subtract 26 from both sides, so we have minus 21 is equal to b. And now we can finish filling in our line equation, so we have y is equal to 13x minus 21. Okay, here we want the slope of a line that's perpendicular to the line 2y minus x equals 3. Now remember, lines that are perpendicular have slopes that are negative reciprocals. Alright, so we start by finding the slope of this line, and we have to put this in standard form first, y equal mx plus b, so we're solving for y. Alright, so let's start by adding x to both sides. So here we have 2y is equal to x plus 3, and then dividing by 2 on both sides, and we have y is equal to 1/2 x plus 3 over 2. So this line has slope 1/2, so we'll take the negative reciprocal of that, and our line has slope minus 2. Alright, now we want the slope of a line that's parallel to this line. Parallel lines have equal slopes. Okay, so if we put this in the form y equal mx plus b, we'll be able to see its slope. So just subtract 2x from both sides, so we have y is equal to minus 2x plus 5. And so we see that the slope is minus 2. In number 14, we have a piecewise defined function. It's defined in 2 rows, and we see that for x less than 1, f of x is equal to 5, and for x greater than 2, f of x is equal to the part of the line 2x plus 3. Okay, so in part A, we're asked to find f of minus 30. Well, since minus 30 is less than 1, the function is equal to 5 for all x values less than 1. So this would be f of minus 30 is 5. And now f of 10, well, 10 is greater than 2, so we use the second row to figure out what f of 10 is. So f of 10 is equal to 2 times 10 plus 3. Okay, substituting into 2x plus 3. That's 20 plus 3, so that's 23. All right. In part B, we're asked for the domain of our piecewise defined function. Well, the domain is right here. Okay, it's listed right there. So the domain is x less than 1, x greater than 2. Okay, so that's our domain. And now for the range, it's a good idea to graph. Okay, so let's look at a little graph, a very rough graph of this function. All right, for when x is less than 1, let's say this is 1. When x is less than 1, f of x is equal to 5. So let's say this is 5 over here on the y-axis. So we have this horizontal line at y equals 5 to the left of 1. And now when x is greater than 2, let's say this is 2 over here. So to the right of 2, we have this line 2x plus 3. When x is equal to 2, substitute in, and we have 2 times 2 is 4, plus 3 is 7. So let's say this point over here, and I draw a little open circle at 2, 7. Open circle because x is not equal to 2, x greater than 2. And this, so we have a line with slope 2 starting at this point 27. So that would look something like this. So this is a piece of the line 2x plus 3. So now we're interested in the range. Well, we see that y is equal to 5. Okay, along this piece of the graph. And along this piece of the graph, we have y values that are greater than 7. See, they start over here at 7 and they go up. So we have y greater than 7. Not greater than or equal to, because this is an open dot. All right, so that's the range. Here we have two functions, f of x and g of x, and we're asked to find f of g of x. F circle g of x, that's the same thing as f of g of x. So we're going to be substituting g of x into f. All right, so let's start with f, and we put open parentheses instead of x. And we just substitute in g of x here. Okay, here on the right-hand side, we'll write the expression. We'll write what g of x is equal to, x plus 3. Okay, that's g of x right there. And so that's it. That's f of g of x. But if we're going to simplify this, let's do that. Let's multiply this out, and we have x squared plus 6x plus 9. So that would be 2 minus x squared minus 6x minus 9. And that is minus x squared minus 6x minus 9 plus 2, that's minus 7. All right, so that's f of g of x simplified.